Okay. We are in module number 9 for our CNIT 121 class. The next couple of chapters is really a bunch of overview context. We're not going to dive deep into a lot of things. It's really covering other topics that are in the realm of digital forensics. The big focus for the rest of the semester is actually in what I guess is the only best way to describe it is your final exam, which are the 3 small and 3 large cases that I will continue to encourage you all to use use Discord and talk with each other and collaborate to solve those cases, because those even the small ones are not necessarily small in comparison to the large. But I highly discourage anyone from trying to solve them completely on their own. Highly encourage you to work together. So module 9 covers a number of things in regards to the cellular network. The cellular network is a group of cells or geographic areas within a network. A cell site is a tower located in a cell. A mobile switching center switches data packets from one network path to another on a cell network. If the user calling is managed by another carrier, the call will be routed from the mobile switching center to the public switch telephone network, an aggregate of all circuit switch telephone global networks. I'm sure you have seen this in many forms, including looking like a tree. These are cell towers, usually 200 feet up in the air, with transmitting panels in the middle, and the others are the receiving panels. These towers are controlled by the base station controller, who handles frequencies and handoffs as mobile equipment move from one cell to the next. A soft handoff is when cell communication is conditionally handed off from one base to another, and the mobile equipment is simultaneously communicating with multiple base station controllers. A hard handoff means that communication is only handled by one base station controller at a time. For cell phones, understanding how a cell network is structured is good to understand the type of evidence that can be retrieved from a carrier's network without access to the suspect's device. Law enforcement can request cell site records from a carrier, specifying the format they wish the evidence to be in. Law enforcement can contact the network carrier and explain the user information they seek, as well as ask the customer not to be notified. Law enforcement can request a suspect's records be preserved for 90 days, pending the acquisition of a search warrant. Only court orders can extend this for an additional 90 days. Law enforcement can also obtain subscriber information, which is things like the name, address, social security number, call detail records that are used for billing, like the phone call or phone number that was dialed, the duration, the dates and times, what cell sites were used. They can also access PIN unblocking key codes to bypass any SIM protection in order to corroborate evidence from the carrier and the user's device. Our devices are actually all called mobile stations. They are the handsets and the subscriber identity module, or SIM. An international mobile equipment identity, the IMEI number, uniquely identifies every handset. The initial 6 to 8 digits are the type allocation code that identifies the type of wireless device. In the notes, I have linked a site that'll show you specific details about devices. The Universal Integrated Circuit Card is a smart card that identifies a subscriber on a GSM or UMTS network. For GSM, this is the SIM card. For UTMS, it's a universal SIM card. A mobile equipment identifier, MEID, is an internationally unique number for CDMA devices that was previously called the electronic serial number. The number has the manufacturer code and a serial code for that device. For CDMA devices, they have a subsidy lock, confining the subscriber to a certain cell network so that it can be sold for free or at a subsidized price. This means a phone's file system cannot be acquired with an active subsidy. For example, an iPhone could be $99 in some weird world, but you are locked to a particular carrier and contract, whereas a phone paid at full price can be unlocked. This is good to know because the phone may have been used internationally with a SIM card purchase abroad. This type of lock is usually not found in Europe. All US phones have a FCC ID, indicating the device is authorized to operate on radio frequencies within the FCC's control. There are manuals and more information at a site I provided in the lecture notes. Now this little sucker, the SIM card. The International Mobile Subscriber Identity is another internationally unique number on a SIM. The mobile country code is the first 3 digits, with the preceding 2 to 3, the mobile network code. A mobile subscriber identity number is created by the carrier and identifies a user on the network. The mobile subscriber ISDN is the phone number for the subscriber. SIM cards also have integrated circuit card ID, a 19 to 20 digit serial number located on the card, helping to identify the origins of a SIM card. The mobile switching center is where user information passes to the home location register. This database has subscribers and public or PII, along with other information from above. The visitor location register is a database of roaming subscribers. The equipment identity register that tracks IMEI numbers and decides whether one is valid, suspect, or stolen. And the authentication center that could use things like encryption algorithms for the wireless communications. All of that to say, your activity on a cell phone is not anonymous. There are databases, there are logs of who you called, where, through what tower, what network provider. Your SIM card is basically like a MAC address that is definitely unique internationally. There is quite the amount of unique information for every device. Just FYI, if you thought you were being anonymous with your phone. Now on to the different cellular network types. A mobile network operator owns and operates their network, like these guys. A mobile virtual network does not own their own network, but operates on the backs of the above. Cell telecommunications has evolved from the days of 2G through 5G. 2G used time division multiple access to allow devices to communicate on the same frequency by splitting digital signals into time slots or bursts. The Global System for Mobile Communication, or GSM, is an international standard created in Europe for signal communications. GSM uses the time division multiple access, with the most pervasive standard is 4G LTE. 3G used the Universal Mobile Telecommunication Systems and the wideband CDMA. GSM devices can be used internationally by simply switching SIM cards. The Code Division Multiple Access, or CDMA, is a spread spectrum communication methodology used by Verizon and Sprint. Well, now just Verizon. The Integrated Digital Enhanced Network is a Motorola technology that allowed phones to be used as walkie-talkies. If you didn't know, this little notch is the serial interface for a SIM card. There is EEPROM, where a hierarchical file system exists. The OS, user authentication, and encryption algorithms are in that ROM. The three primary areas of a SIM card file system are the master file, which is the root directory, the dedicated files, and elementary files, where data is stored. Elementary files is where subscriber information is stored. Looks something like this. The EFADN is the abbreviated dialing number, where contact names and numbers are stored. This one down at the bottom, the FPLMN, is the Forbidden Public Land Mobile Network. These are cell networks a device attempted to connect to, but was not authorized to. So it's useful to know where a suspect was located. The second from the bottom has the list of outgoing calls that were made, its last number dialed. LOCI is the area where the user last powered down the phone. So it has a geographical note of where the phone was last on when it turned off. This one is a list of text messages. Since SIMs are PIN protected, investigators usually have 3 attempts to get the PIN correct before it's locked. And after that, they'll have to get an unlock code from the carrier. SIMs can be cloned, and most software tools are able to clone SIMs. SIMs can also help an investigator determine whether a text message was read, deleted, unread, sent, unsent, based on the status flag, which is saved in binary. The multimedia text messages can be carved out using forensics tools. Rich communication services like WhatsApp and Signal maintain that same legal intercept standard as SMS. So it is possible, even though we can't read the message with something like WhatsApp or Signal, can't read the contents of the text message, we can see if a user deleted it, if a user read it, if a user unread. All this helps in a case because if the suspect had read it, then prosecution or defense knows that the suspect knew of whatever was said. They can't deny they didn't see it. Or if the suspect was the one who sent it, then they have non-repudiation. We know this user is the one who sent that specific text message. A quick look at Android. Based off the 2.6 Linux kernel, bought by Google in 2005, maintained by the Open Handset Alliance, can be found on all networks. You also find Android on cars and media entertainment systems, smart TVs, and a bunch of other places. Some of the common partitions that you see in Android are the boot, who has the boot code for the device, includes the kernel and a RAM disk, which are associated together. The MK boot IMG is a Linux command line tool for developers. It allows developers to create new boot images. It's possible to access the boot partition by pressing certain keys on the device, and that depends on what device. There is the /system, which contains the Android framework, the recovery, which has a recovery image, the cache that stores temporary data, miscellaneous, used by the recovery partition. There's the user data, who has user installed apps and data. This is usually the most important partition from a forensics perspective because it contains all the user activity associated with mobile applications. There is a metadata folder, which is used when the device is encrypted. There's the Dalvik cache. It stores .dex files. The applications folder that has the APK, Android application package files. There is a data folder. It's a subdirectory in each application that has a SQLite database. And then there are other miscellaneous stuff like DHCP, Wi-Fi, and any system packages. When initially examining any Android, it's helpful to identify what apps are installed, which is normally under data system packages.list. Some challenges. Gaining access to evidence on a suspect's computer is challenging given advances in encryption. This means that experimental techniques may be the only course of action for an investigator. Since forensics is a science, whatever action was taken must be documented and repeatable. Circumventing encryption often means destroying the device beyond repair to access the data. Even then, it might not be successful, and the prosecutor should be aware of these types of things. Mobile device forensics requires the entire system and may not be able to separate the volume during the examination. Write blockers are typically not an option, and creating two copies may not yield the same hash. Outside of logical and physical ways to extract evidence from Android, there's also JTAG, chip-off, and ISP. JTAG is the Joint Test Action Group, an IEEE standard for testing, maintenance, and support of assembled circuit boards, and is an increasingly important way to bypass security and encryption on a smartphone. This picture that I'm showing you here is using a RIF box used to acquire data from the circuit board of a cell phone. A full dump of memory can be obtained by extracting the contents of one of the chips. The connectors are soldered into the JTAG points on the board, and the voltage is applied on the board using a cell phone battery. When devices like Cellebrite can't be used, JTAG is next. The last resort is chip-off. It's an expensive process that requires specialized tools that is not always successful. The chips are physically removed from the board and added to an adapter in order to be read. In-system programming, or ISP, is the practice of connecting to a chip, a memory chip, in order to access the files that are stored. It's less invasive than the prior methods I mentioned. Emergency download mode is a technical recovery feature on Androids that have Qualcomm chips. The device restarts to this mode if there are any errors or faults detected. This can be used to access and make a forensic image of a device as long as it's supported. It can be used to modify the bootloader through a rooted ADB shell. Androids are typically secured by pins, which are 6 to 8 digits, passwords that are stored in /data system pc.key, a pattern lock, which is /data system gesture.key. They can be opened with via extract or with biometrics. There are many open source and commercial tools to perform forensics on Android. In most cases, the device has to have USB debugging enabled in order to allow the Android debug bridge, or ADB, to connect and perform the work intended. Applications can also yield valuable information for an investigation. Most apps have some form of SQLite database within them and are written in Java. For example, every time a phone sees a Wi-Fi hotspot, it is recorded on the device, regardless whether the user connected or not, in a file called cache.wifi. This can be used to map out where the user was going. Apps like Facebook record everything from contacts, chats, photos, and searches. Your standard procedures for handling handset evidence is covered by NIST SP 800-101. As usual, all your tools should be validated prior to their use in investigations to determine the expected data can be extracted and the process can be reproduced with the exact same outcome. According to the US Department of Justice guidelines, in the electronic crime scene investigation, a guide for first responders, the following steps should be taken: securing and evaluating the scene, ensuring the safety of individuals and to identify and protect the integrity of potential evidence, documenting the scene, creating a permanent record of it, recording both digital and conventional evidence. There's the evidence collection, collecting traditional evidence in a manner that preserves their evidentiary value, packaging, transportation, and storage. taking the adequate precautions and maintaining a chain of custody. Proper containment means removing the device from the network with use of Faraday boxes like these. Remember that the issue with mobile devices is they require frequent charging because the device will boost the signal in an attempt to connect to a cellular network, along with other applications trying to communicate. Once the phone shuts down, there is risk of encountering a user's PIN or password to unlock. On a side note, the use of signal jammers is illegal even for law enforcement because the FCC has stated, should an emergency situation arise, a person in distress may not be able to contact emergency services. Cell phone carriers should be contacted to ensure that the phone is removed from the network. It's possible for a criminal to report a lost phone and have it erased before law enforcement can seize it. A couple of cell phone forensic tools are things like Gray Key, created by Gray Shift, that's used for iOS devices. It's only available to law enforcement and can bypass pins. There's BitPim, an open source tool that views and manipulates CDMA phones, along with many Qualcomm chipsets. There's the Mobile Edit Forensic organizational tool for a user's contacts, messages, media, and other files installed on the system. It has a mobile version. There's E3, which comes with a list of tools, and the most infamous of them is Celebrite. A major difference between computer and mobile forensics is file fragments. When an SMS message is deleted on a phone, you can generally be certain it is removed and no message fragments exist. Physical extraction can redirect some deleted files. Now, if there is an absence of mobile forensic imaging tools, well, an investigator is then forced to do a manual examination, taking pictures of the screen as they go through the phone's contents. Out of all that, old school pictures still count. Recalling Module 7, a warrant must be obtained for a cell phone, with exceptions including consent, incident to arrest, or exigent circumstances. Warrant should describe the cell phone and include details like the make, the model, the manufacturer, the phone number, and location of the device. If available, the IMEI or MEID should be included along with the type of device that is being acquired, or the type of evidence that is being acquired, like text messages, contacts, etc. Questions? It depends. Sometimes the older phone makes it harder because you'll need to take pictures like this, this tool. And other times a smartphone will be harder because it'll have things like TPM and full disk encryption. I think it depends. Either way, when the phone runs out of battery, that's when things get really tough. What other questions do you guys have? If there are none, I can repeat the work. Okay, seeing no questions. As I said at the beginning of the lecture, there is no more labs in any of the modules going forward. It's all just lecture, because I really want to put your focus on these cases. I highly encourage you to work together, to use Discord, use the text channel and voice channels to communicate with each other and help solve these cases and write your reports and submit them. These cases will take time. They are complex. They are as close as I can get to a real case without, going too real. And I highly discourage anyone from working alone. I highly encourage you to work together, because again, these cases are big. And I really want you guys to have plenty of time to focus on them and work together through them, which is why there is no more other classwork, and it's just pointing to the cases until December 7th. Any questions on the cases? Okay. They are not in a particular order. You can choose to do them in whatever order you want, whatever order your group decides to tackle them. If you want to start with the large cases first and then do the small, or do one small, one big, it absolutely doesn't matter. My biggest thing is working together. Working together to solve them. Because because it's just not. It's not going to be fun to do it all on your own. Much better to do it in a team. So yeah, please collaborate with each other. Please use Discord. Okay, so seeing no other questions about the work or the content, I'll stop the stream.